All right, today we're going to go over the coronavirus outbreak regression analysis. So I'm actually going to use a lot more information than what you guys had to use. So you could have just used up to, I think, like the 15 days. I'm going to pretty much use a lot more data. And the reason, guys, is whenever you're doing any type of regression analysis, you want to make sure that you're using as much information as possible, because the more information there is, the more accurate your data is going to be, the more accurate your regression analysis is going to be. It's going to help predict better. So that's it. All right, so here's the actual worksheet. If you printed that off, that's fine. You don't have to do it on this worksheet. If you just want to do it on a separate sheet of paper, take a picture of that. You can email me that. You can attach it to the assignment itself. If you want to make a Google Doc form, Google Doc, that's okay as well. But you have to. It has to be done correctly. You can't just like. I would not recommend trying to copy and paste this into a Google Doc. It's just going to get messy and not going to work. I wouldn't even try to open this with Google Docs, to be honest. So, personally, I would I think the easiest way for me to do it is I usually just take a screenshot if it doesn't open the PDF. But if you want to make a Google Doc, that's fine. I actually will share a Google Doc if there's any issues. So if you need to use Google Doc, let me know. I started one because somebody tried to use one and I kind of fixed theirs. So I can always do that. Now we have filled out this before in the coronavirus data activity. So I'm going to do that first. Now I'm going to just kind of go and show you what I've done so far. So, all right, so here's the images that I've been sharing a little bit with you guys that has all the data that we need. So we need all this data so then we can kind of go through and graph this. So that's the first thing you're going to do is you're going to take this table and you're going to fill out the graph. I put a graph right here. So we go, if you include the newest data, so that's from yesterday's data, is 1,933 cases. So we got to have up to 2,000 that goes on our y-axis. So our y-axis is going to be the number of confirmed cases. So right here we're going to have number of confirmed cases. So y is going to be that's up and down, is going to be the number of confirmed cases. All right. Our x value right here, that's going to be just the number. That's the number of days. All right. So we go up to, we have 22 days. And like I said, we need to be pretty close to 1900. So I'm going to keep just the x-axis. I'm going to keep those to go by ones. So when I use this, I'm not going to put 1 every time because it's just going to get really messy. So like I'll put like 5 there. And then I'll put 10 there. 15. There's 20. And there's 25. Now, the y-axis is a little bit trickier. So I went by hundreds. It's not going to help me at the end of this graph with all the new numbers, but for the original 15 points of data, it will be plenty and actually help us, until like really the end of it. All right, so I'm going to graph. Now I have 3. The beginning of this is going to be very, very difficult because they're all so close to the x-axis. 3, 3, 4. 13's a little bit higher, or 4, 5, then we're at 13, 26, 37. I mean, these are all going to be almost like right on this line, and I'm just not doing a good job graphing it by hand. So we'll try it again. 3, 3, 4, 5, 13, 26, 37, there's 50, 67. Now it's going to get a little bit easier because they're starting to increase a little more. 88, 119, 169, 247, So 247 is what we're looking for. And then 351. So I got to go 14, 351. Then 442. And now it's getting a little bit easier to graph. And now 16 is 564. '17 is 704. '18 is 867. '19 is 1137. So 19 comes like up here. 20 is 1406, so it's pretty high up here. Then 1653. Then 1933. We'll say it goes all the way up here. So this is kind. Oh, let's see if I can make that a little better. I'm just gonna get kind of. All right, it's kind of just the graph. All right. So that was kind of hard to graph, but we did okay there. So now, it says use regression model. That's that website right there. Remember we did that. So I'm gonna look at that now. All right, so I made some screenshots to show you what you're kind of typing in. So that's what I'm going to show up now. So I'm looking for number 2. I went to this website. So number 2, I went to this website right here. All right, I went there, and then I typed in this stuff. All right. So you notice right here in these boxes right here where it says right there, that's where I'm putting the x values, 1 to 22. Right here is where I put the y values. All right, just put a space in between them. I left all of these clicked for right now. If you notice all these right here, they're all clicked on because maybe we don't know. Like I already know which one it's going to be. So like if I was doing this, like when I made your guys's picture for Firestarter 7, I unchecked everything that I didn't want to show up. But when we don't know, we have to pick all of them, and then we got to see which one has the biggest error. All right. So I'm actually going to delete this picture right here. We're going to get rid of that. That might make things look a little bit better. So I went to planetcalc.com. I put that stuff in, and this is what I got right here. All right, that's what I put in. Then the next thing that shows up. So once I hit calculate, or it actually will show up automatically, I get this page, and this is where they actually do the math for you. They put into like some programming math, and it spits out what's the best graph for it, what's the best function. So although like if we just look at the picture of what's going on right at this time, it kind of looks like, if you look at the graph pictures, it kind of looks like cubic right here would be the best one, like visually when you look at it. Now the problem is math-wise that doesn't add up. That's because it's based on what's going to happen in the future. So it actually has a better average relative error here or here, which are almost the exact same because they're just two different ways kind of do the same idea. I think you guys will kind of see like this one a little bit better. I think most math guys would kind of like that one a little bit better, but it doesn't really matter which one. So that's actually going to be the one that we use when we write out our answer. All right. And the reason we're using that is because it's the 31% error. All right. So when we did our regression analysis on that little calculator, it gave us this thing right here. It said y equals 2.5702 times 1.3869 with x as your exponent. So that's your exponent. That exponent is the number of days. Now, I don't really like writing it like that, so I'm actually going to write it like this. 2.5702, then parentheses 1.3869 to the x power. It's the same difference. I think it's easier to write that way personally. All right. Now what I'm going to do is I'm going to put 30 in for there, 60 in there, and 90 in there. Now you're going to see why when we did this, it had that rate of error, and it was a pretty high error rate. 30% was pretty high. You're also going to see why this is a very simple math. Even though it doesn't seem simple to you guys, it's actually very concise, as in we're only taking into account one idea. We're just looking at number and spitting out a math equation. We're not taking into account population density, total population in general, and things like that. So that's a bunch of stuff we're not taking into account. So these numbers will get way off really fast, but it's still a good way to start off looking at these numbers and at least have an idea of what we're looking at. So for number 3, I'm gonna do everything the exact same. This time I'm gonna have y equals 2.5702 1.3869 all to the 30th power. So that's what I'm doing for 30 days is in red. I put in my calculator. I get y equals 48,619. So after 30 days, so just look at the huge increase from day 22 to day 30. That's what they think is going to happen. Now, like I said, that's anticipating a lot of things. It's not taking into account social distancing, which is kind of the I messed up those numbers. It should be 46,916. I don't know what I was thinking. So this should be 46,916. I had like some weirdness going on. So 46,916. So we have 46,916. Now I'm doing the same thing for 60 days. So this time I'm going to do y equals 2.5702 parentheses 1.3869. This time to the 60th power. All right. When I do that, it's going to give me this gigantic number, which once again really shows that we're maybe we don't have enough information to make a fair regression analysis yet. 856 million. Better double check my math. Yeah, 856,398,000 and 324. So, once again, this kind of shows us the limiting capacities of just taking straight data with no other applications, because we don't even have that many people in Ohio. There's not even there's not that many people in the country. So, if there was an unlimited, there's a reason that this is not. There's a bunch of different reasons why this is not entirely accurate. But like I said, it is a good model, and it's also not accurate because we have been doing things like social distancing and things like that. So the last one is going to get crazy. So it's the same thing: 2.5702 parentheses 1.386. 1.869 to the 90th. That's not negative 90. I don't know why that showed up. To the 90th. So that's going to say y equals, and then it's going to be 1.56 times 10 to the 13th. That's like 1.56 quadrillion, and that's just, once again, it's kind of limiting why this isn't the best application yet. All right. So now, for number 4, you're just going to kind of guess and check. Like, obviously 30 is not, obviously 30 is going to be, if I was to guess about 10,000 people, I wouldn't guess 30, right? So I would say, I'm going to do my same thing, but this time I'm going to guess 25. We'll see what 25 gets me. So I'm just guessing and checking. So 25. So if x equals 25, I get y equals 9,143. That's pretty close, actually. Then I'm going to try 26 just to see the next one. And I get for when I pick this 26th day, I get y equals 12,680. So I would say between the 25th and 26th day for 10,000. Now for 100,000 people, I would say let's try 32. So for 10,000 people, or 100,000 people, so for 100,000, say if x is 32, I get y equals 90,242. I just randomly guessed 32. And then I'm going to randomly guess, I'm going to check 33. So I'm going to get 125,000. I get y equals 125,157. So that's me just plugging into my calculator like I did in number 3. So I would say between 32 and 33. And now for 1 million people, I don't know, I'm going to guess, say 38 maybe? I plug in 38, I get 642,000, so probably not 38. So my first guess was 38. I got y equals 642,000 and some change. So I'll try 40. 40, I get over 1 million, so I'm going to go back to 39. So for 39, I get y equals 890,692. And then I'm going to say 40. There are like more complicated math ways to solve this much faster, but I think it's way above us. So it's a little bit easier just to do guess and check. So 1,235,301. So you're going to say in between the 39th and 40th day. For 100,000 people, in between the 32nd and 33rd day. So finally, number 5. Do these predictions seem realistic? Why do they, or what would it make it so they are not realistic? 1, does not take into account social distancing. We're doing that now, so that's the idea of flattening the curve. It also doesn't take into account population and population density. There's a reason why New York City is hit the worst in the country right now. All right. There's a reason why in Ohio, Cleveland, in Cuyahoga County has more cases than Ashtabula County. A lot of that has to take into stuff in that. And just we might not have enough information. So we might have enough info to make the best equation. So remember, that's that percentage of error. All right. So I think that's going to pretty much finish this. I don't think I gave you any keywords. So keywords will be annoying children. My kids are being very annoying when I'm trying to make this video. So that's it.